In this lesson, we're going to be talking about exponents. Specifically, we'll learn to evaluate exponents and we'll learn to multiply and divide expressions involving exponents. So first, positive exponents come in the form of a raised to the b power, where a is called the base and b is called the exponent. The exponent, so b, tells us how many times to multiply the base, a, by itself. So let's take a look at what this looks like. We have example 1 in part A, we have 3 squared, so 3 is the base, 2 is the exponent, so it's telling us to multiply 3 by itself times itself twice. So this is 3 times 3, which is equal to 9. In part B, notice that the parentheses are around -2, which means that -2 is the base. Okay, so this is equal to -2 times -2, and we multiply it by itself. Oops, that's not supposed to be a 3. I was about to say 3 times. So -2 times -2 times -2 is -8. Okay, and then part C, notice the negative is outside of the parentheses, meaning that the base here is just 4, and the negative in front is like -1 times 4 raised to the second power. So you can think of it in terms of order of operations, where you'll do your exponents first and then that multiplication. Okay, so this is equal to, I'm going to put that as -1, still being multiplied because when something is next to a parenthesis, that denotes multiplication. And then this is 4 times 4, so this is equal to -16. Okay, so it's really important where that negative sign is, whether it's included with the base or whether it's like a -1 being multiplied on the outside. So negative exponents. So I'm going to go through this chart here at the top using 3, and then we'll talk about the rule for negative exponents. So when we have 3 raised to the third power, this means 3 times 3 times 3, which is 27. 3 squared, we just did, is 9. 3 to the first is just 3. 3 to the 0 power. So first, notice the pattern here, that to get from one to the other, we divide by 3. So if we divide 3 by 3, we're going to get just 1. Okay, and that pattern is going to continue. So if we divide 1 by 3, we get 1/3, which is the same as 3 to the -1st power. Okay. This means 1 over 3 squared, which is 1 over 9. And 3 to the -3rd is 1 over 27, or 1 over 3 cubed, and 3 cubed is 27. So negative exponents are causing us to think about fractions. So at the bottom of the slide, I've put the rule there for you, where we have a to the -n power is 1 over a to the nth power, but we're going to do some examples here. Basically, what this is saying is when we have a negative exponent, it changes positions in the fraction. So in this case, we can think of a to the -n as being in the numerator, and to make it positive, it goes to the denominator and that exponent becomes positive, and vice versa is true as well. If your negative exponent is in the denominator, you move it to the numerator to make it positive. So let's practice that. 8 to the -1st power, using our rule, this becomes 1 over 8 to the 1st. So notice it changed positions in the fraction. If you think of this as over 1, and 8 to the 1st is just 8. So this becomes 1 over 8. Part B is what I was talking about with the rule, that it depends on where it is in the fraction. So 5 to the -1st is in the denominator, so we're going to bring it to the numerator to make that exponent positive. So this is 1 times 5 to the +1 power now. You can still put this over 1 if you want, but you don't have to. So this just becomes 5. Okay. Next, simplify, write your answer using only positive exponents. So now we're going to bring in some variables here. So for the first one, x to the -2nd power, it's in the numerator. We're going to bring it to the denominator, make the exponent a +2, and then we can't go any farther with this. So this is 1 over x squared. Part B was similar to the one that we did, the previous example. So in order to make this exponent positive, it goes to the numerator. So this is 1 times y to the 4th, which is just y to the 4th. And then for part C, notice that you're only moving the base with the negative exponent. So in this case, we would not do, let me do it in a different color, x cubed over 2. The 2 doesn't have a negative exponent, so the 2 is going to stay exactly where it is. we bring up x to the negative third to give us x cubed. So 2x cubed is our answer for part C. Next, so the product rule for exponents, i.e. multiplying bases with exponents. So when multiplying same bases with exponents, add the exponents. And this is key. We have to have the same base here. So I'm going to do an example and I'm going to write this out. Some of you noted in your math autobiography that you're not necessarily good at memorizing rules. I totally understand. There is a formula sheet, but also for these, there's not a lot of memorization if you understand what's happening. So x squared is x times x. Okay, x cubed is x times x times x. So together, there's 1, 2, 3, 4, 5 being multiplied. This is x to the fifth. Notice to do that, you can add the 2 and the 3 together. That's why it says when multiplying same basis with exponents, we add the exponents. Okay, so the rule, according to the formula sheet, is written there on the bottom for you. So we'll practice this a little bit as well. Simplify, write your answer using only positive exponents. Okay, so remember with multiplication, you can multiply 2 times 3, 3 times 2, and you'll get the same answer. Okay, so when you have numbers that are being multiplied as well, we're going to multiply negative 5 times 3, and then we're going to multiply y to the fourth times y to the second power. Okay, so this is negative 5 times 3 times y to the fourth, y to the second. Negative 5 times 3 is negative 15. And what? Oh, that's negative 15. Y to the fourth times y to the second is y to the sixth. Okay. Part B, same idea. We're going to multiply our numbers together, 4, negative 3, and 2, and add our exponents. So 4 times negative 3 is negative 12, times 2 is negative 24. And this is going to be then x raised to the 9 plus 7 plus 5. So this becomes negative 24 x to the 21st power. Okay. And for the last one, part C, we have 2 and 3. And then we also have x to the negative 6 times x squared. So 2 times 3 gives us 6. X to the negative 6 times x squared. Okay. So this gives us 6x to the negative 4, and we're supposed to write our answer using only positive exponents. So remember, this piece is the only thing we have to move in order to make the exponent positive. The 6 does not have a negative exponent. Okay, so this becomes 6 over x to the fourth power. Okay. Dividing bases with exponents. So when dividing same bases with exponents, we subtract the exponents. Again, I'm going to show you what this looks like. So x to the seventh is 1, 2, 3, 4, 5, 6, 7 over x squared. We have some common factors that can cancel out. And we're left with 1, 2, 3, 4, 5, which this is the same as 7 minus 2. Okay, so if you're looking at the rule, x to the seventh over x squared is x to the 7 minus 2, which is x to the fifth power, exactly what we just got. Okay, a couple of examples. Simplify, write your answer using only positive exponents. So you can write these out. Y to the 6 would be y times y times y times y times y times y. Y to the fourth cancel, and then simplify as much as possible. Using what we just talked about where we would subtract, this would be y to the 6 minus 4, which is y to the second power. Okay. For part B, I'm going to do that one in two ways. So first, I'm going to write it out. X to the third over x to the eighth. 3, 4, 5, 6, 7, 8, and let me just count. Okay, so we have some common factors. Notice all of our x's are left on the bottom. So there's a 1 on top, because those don't go away. They're not becoming zeros, they're becoming ones, over x to the fifth. Okay, if you use the rule, you would get x to the third minus, or x raised to the 3 minus 8, which is x to the negative 5, and you would have to make sure your exponent is positive. Okay. The last thing that we're going to talk about is the power rule for exponents. So raising a power to a power with exponents, we multiply the exponents. Okay, and again, I'm going to show you what this looks like. So x to the second is what our base is, and 3 is our exponent. So this is x to the second multiplied by itself 3 times. we just talked about multiplying, or the product rule, so this would be x to the 6th, okay? 2 plus 2 is 4, plus another 2 is 6, or we get that from doing 3 times 2. So let's do a couple of examples. Example, simplify, write your answer using only positive exponents. So for part A, again, you can write this out as y to the 4th. Not 5 times, I was going to say 5 times. So 4, 8, 12, 16, 20. So this is y to the 20th. Okay, it's the same thing as doing y to the 4 times 5. That's going to become important for part B, because now we have 2x cubed times y squared, all raised to the 4th power. So this 4th power has to go to each of the pieces inside, okay? And if you wanted to write that out 4 times, the base, you would see that. Okay, 2 doesn't have an exponent, so it's assumed to be 1. Not 0, anything to the 0 power is 1. If there's nothing written there, it's assumed to be 1. So this is going to be 2 to the 1st times 4, x to the 3rd times 4, y squared times 4. And now we simplify. Okay, so this is 2 to the 4th, x 3 times 4 is 12, y 2 times 4 is 8. Okay, and then 2 to the 4th, 2 times 2 times 2 times 2 is 16. So we're getting 16x to the 12th, y to the 8th for our final answer. Okay. For part C, you can consider order of operations here. We have x to the 5th raised to the 4th power times x squared raised to the 2nd power. So we apply our exponents first. These parentheses here are denoting multiplication. Okay, so this is x to the 5 times 4. These are next to each other, so they're being multiplied. X to the 2 times 2. So this is x to the 20th times x to the 4th, which is x raised to the 24th power. If you have any questions, feel free to reach out to me.